Hello, my name is Neel Raj. I'm a second year computer science major. My research advised by Professor Jennifer Schneider was on data informed emergency response. The agenda for this presentation will discuss the motivation behind the research, the methods involved, preliminary results, and the future work for this research. So imagine RIT. While we're having fun doing all these activities, visiting exhibits, eating food, what if there was an emergency? What if there was? But relax, emergency managers are thinking about this both at the facility level, like Imagine RIT, and at the community level. But think about it especially in terms of what we've recently lived through. Well, emergencies generate a lot of data. And since emergency management is foremost about knowing what is going on, situational awareness, data mining of historical data can be useful to emergency managers trying to both plan and respond. Of course, historical data does not always represent every possible emergency. For instance, how many pandemics have we had? But it does give us an ability to understand trends and does provide us a baseline to help improve future emergency response. And even in COVID, data mining is giving us an ability to plan and respond more effectively for the future. So, what exactly do emergency managers do? Well, they plan for emergencies, either through mitigation planning or response planning. Well, what is mitigation planning? Mitigation planning is quelling hazards so that a big response to emergencies is not necessary. Now, this requires situational awareness. As previously said, situational awareness is about knowing what's going on. Now, there's two types of situational awareness. There's predictive situational awareness, which is key to stopping an incident from growing, key to stopping future types of that incident, and requires a researcher or the emergency managers to know where events are happening, how long these events take to end, and what day they're happening on, things like that. The other form of situational awareness is what helps us live better in the moment. Now, the other form of planning that emergency managers do is response planning, which deals with resources such as fire, EMS, police, and other resources, including tow trucks, the water department, social workers, and debris removal. Overall, there are two tiers of responders used in response planning. So, goals. Resources such as police, EMS, and fire need to be positioned in appropriate locations. For larger disasters that span multiple towns, multiple areas, sharing of this resources becomes even more important, especially since public budgets are always strained, and having the personnel for these resources is a determinant or a driving factor to effective response. Now, these constraints are a big part of smaller localities that depend on sharing these resources. So, an appropriate model is necessary for creating dynamic responses to larger disasters, to any disasters that span a jurisdiction, multiple jurisdictions. So, selected previous work between RIT and data from Monroe County 911 dealt with decision making, working with historical data and drawing up trends and understanding what exactly has been happening in the past, as well as creating a predictive model on resources. All of these previous work revolved around emergency response research approach. Now, this research really focused on building an emergency response that reflects actual changes and constraints in a community, exploring resource capacity, emergency resolution. So, we're interested in modeling functional policy driven decision making over time to improve emergency resolution, leading to the use of cellular automata. Cellular automata is textbook defined as discrete abstract computational systems that help in modeling dynamic complexity in science and engineering. They comprise a countable set of simple units called cells, like it is in the name. And cellular automata allows for modeling independent as well as collaborating cells to represent characteristics of subjects used in modeling systems. Now, for the purpose of the research, cellular automata is being used to model resource availability and resource allocation. In addition to researching cellular automata and designing how it can be implemented in this research, data preparation and preprocessing was needed to clean the data so that meaningful information could be extracted from the data to help with analyses. More of this research product requires the use of two data mining techniques, Parser density estimation and hierarchical clustering. Parser density estimation is a data mining method to show a distribution of a specific variable. Now, in this case, Parser density estimation is used to develop heat maps from the 911 data. Then there's hierarchical clustering. From performing hierarchical clustering on the 911 data, the center of major locations of emergencies within Monroe County, as well as the relative time to respond to an emergency at that location, would be revealed. This approach is important as it provides the researcher, as well as decision makers, the emergency managers, with meaningful information to help improve emergency responses for the future. The 911 call data sets. Now, the span of the data that we have runs from 2006 to 2010, meaning that we're only dealing with historical data, which allows us to determine trends to use later for other analyses. Now, there are some issues with the data set. There's a lot of missing data on timings as well as locations. It makes it difficult to draw full analysis from all of the data. And then there's the recent data. Been in touch with 911 managers to get recent data, and recent data will help us assess the trends that we're seeing from historical data. And this will help us evaluate resource placement as one of the goals mentioned. Older data helps inform the model building process, but recent data allows us to really test the model. So modeling jurisdictions using cellular automata. So what exactly is a jurisdiction? Well, it's a unit of government, such as Pittsford. It's a town. Now, the top left cell is a cell of a jurisdiction. We call it Town A. Now, this Town A contains several resources and information about them, which is used for planning and handling emergencies within that town, within that cell. The Town A contains a police resource, an EMS resource, and a fire resource, which contains information about how they can be used. The bottom right is a neighboring cell. A neighboring cell is a combination of two jurisdiction cells and represents the collective resources and information on those resources between the two towns and jurisdiction cells. Now, as we said previously, cellular automata is about collaborating. Using two cells together allows us to build one giant cell, a neighboring cell, and then from that we can combine two neighboring cells together, four neighboring cells together, and they can all encompass a whole entire county. So preliminary results. We're able to generate heat maps from our Parser density estimation. Now, these heat maps represent accidents in Monroe County, a distribution of the accidents in Monroe County, with the latitude and longitude boundaries on the graphs represent the overall area of Monroe County. Darker points represent areas with a higher number of accidents. Now, clicking through and seeing all the data distributions for the span 2006 to 2010 will allow us to draw some initial analyses, trends on the data distribution. So in 2006, 2007, 2008, 2009, 2010. From all the graphs across 2006 to 2010, the majority of the accidents in Monroe County occurred between 43.1 and 43.2 degrees latitude and negative 77 degrees and negative 77.5 degrees longitude. Now, emergency managers learn from this historical data and these trends from the distributions, and this helps inform their decision making. So the current status is working with Monroe County 911 Department to get new data for recent years to assess the trends that we're seeing from the heat maps, as well as mining new information to understand resource placement and to come up with a model to show better resource placement if that is possible. So future work. We plan to build these heat maps and develop the cellular automata model to forecast historical trends so that emergency managers have better tools at their disposal to support resource planning across space and time and serve mutual assistance needs more effectively. Understanding historical differences in 911 call data will allow researchers and the emergency managers to determine what changes are needed to help improve 911 response efficiency and resolution. Now, the other thing for future work is scaling the project, moving from county to neighboring counties, from neighboring counties to the state, and then eventually the nation. Now, in order to do this, we need to work outside a county boundary initially, right? Because we're dealing with Monroe County. Monroe County, as you can see, is surrounded by other counties: Orleans, Genesee, Wyoming. And it requires knowing data and knowing resources in other counties to help with emergency management, because that is the goal: regional situational awareness. So that is an aspect of the future work for scaling the project, understanding that we need new data and understanding that they might have to be a lessening of jurisdictional autonomy to achieve both efficiency and sufficiency when dealing with larger emergency events that transcend county borders. Now, from the pictures, you can see that the cells would represent counties and then eventually the states and then the nations. References. Thank you for attending my presentation.